Hello and welcome back. So what we have here is position 23. We need to take a position in top 10 to get promoted to the Diamond League. People is getting crazy. They're already at 3,000 points, nearly 4,000. And yeah, we need to go and continue our course, take those points, and get promoted. Let's resume this course. How could they do 3,000 points in a few hours? They just did.
Let's dive into the structured or
entire learning path. Okay, let's go.
Relational database services. First up is Cloud SQL. Why would you use a Google Cloud service for SQL when you can install a SQL Server application image on a VM using Compute Engine? The question really is, should you build your own database solution or use a managed service? There are benefits to using a managed service, so let's learn about why you'd use Cloud SQL as a managed service inside of Google Cloud. Cloud SQL is a fully managed service of either MySQL, PostgreSQL, or Microsoft SQL Server databases. This means that patches and updates are automatically applied, but you still have to administer MySQL users with the native authentication tools that come with these databases. Cloud SQL supports many clients, such as Cloud Shell, App Engine, and Google Workspace scripts. It also supports other applications and tools that you might be used to, like SQL Workbench, Toad, and other external applications using standard MySQL drivers.
Cloud SQL delivers high performance and scalability with up to 64 TB of storage capacity, 60,000 IOPS, and 624 GB of RAM per instance. You can easily scale up to 96 processor cores and scale out with RAID replicas. Currently, you can use Cloud SQL with either MySQL 5.6, 5.7, or 8.0, PostgreSQL 9.6, 10, 11, 12, 13, 14, or 15, 2017, or
on some other services provided by Cloud. Let's focus on some other services provided by Cloud SQL. In HA configuration, within a regional instance, a configuration is made up of a primary instance and a standby instance. Through synchronous replication to each zone's persistent disk, all writes made to the primary instance are replicated to disks in both zones before a transaction is reported as committed. In the event of an instance or zone failure, the persistent disk is attached to the standby instance, and it becomes the new primary instance. Users are then rerouted to the new primary.
So
SQL. In HA configuration, within a regional instance,
15, or 8.0, either of the Web, Express, Standard, or Enterprise, SQL Server 2017 or 2019 editions.
Let's focus on some other services provided by Cloud SQL. In HA configuration, within a regional instance, a configuration is made up of a primary instance and a standby instance. Through synchronous replication to each zone's persistent disk, all writes
man, it's too fast.
and a standby instance. Through synchronous replication to each zone's persistent disk, all writes made to the primary instance are replicated
Jesus Christ, why they made so fast?
in a regional instance. The configuration is made up of a primary instance and a standby instance.
Okay.
Through synchronous replication to each zone's persistent disk, all writes made to the primary instance are replicated to disks in both zones before a transaction is reported as committed. In the event of an instance or zone failure, the persistent disk is attached to the standby instance, and it becomes the new primary instance. Users are then rerouted to the new primary. This process is called a failover. Cloud SQL also provides automated and on-demand backups with point-in-time recovery. You can import and export databases using MySQL dump or import and export CSV files. Cloud SQL can also scale up, which does require a machine restart or scale out using read replicas. That being said, if you're concerned about horizontal scalability, you'll want to consider Cloud Spanner, which we'll cover later in this module.
Choosing a connection type to your Cloud SQL instance will affect how secure, performant, and automated it will be. If you're connecting an application that is hosted within the same Google Cloud project as your Cloud SQL instance, and it is co-located in the same region, choosing the private IP connection will provide you with the most performant and secure connection using private connectivity. In other words, traffic is never exposed to the public internet. Note that connecting to the Cloud SQL private IP address from VMs in the same region is only a performance-based recommendation and not a requirement. If the application is hosted in another region or project, or if you're trying to connect your Cloud SQL instance from outside of Google Cloud, you have three options. In this case, I recommend using the Cloud SQL auth proxy, which handles authentication, encryption, and key rotation for you. If you need manual control over the SSL connection, you can generate and periodically rotate the certificate yourself. Otherwise, you can use an unencrypted connection by authorizing a specific IP address to connect your SQL server over its external IP address. You will explore these options in an upcoming lab.
To summarize, let's explore this decision tree to help you find the right data storage service with full relational capability. Memory Store provides a fully managed, in-memory data store service for workloads requiring microsecond response times or that have large spikes in traffic, as seen in gaming environments and real-time analytics. If you don't need an in-memory data store, but your use case is relational data used primarily for analytics, these workloads are best supported by BigQuery. However, if your relational data workload isn't analytics, the choice lies between Cloud Spanner and Cloud SQL. And if you don't need horizontal scaling or a globally available system, Cloud SQL is a cost-effective solution.
Let's take some of the Cloud SQL concepts that we just discussed and apply them in a lab. In this lab, you configure a Cloud SQL server and learn how to connect an application to it via a proxy over an external connection. You also configure a connection over a private IP link that offers performance and security benefits. The app we chose to demonstrate in this lab is WordPress, but the information and best practices are applicable to any application that needs an SQL server. By the end of this lab, you will have 2 working instances.
Okay, so we'll try to complete this in half an hour. Oh, sorry, so I wasn't sharing the web browser with you. However, I just had a look at these videos about Cloud SQL. So it's just 7 minutes of my face reacting like, ah, ha, ha, ha. Okay, so implementing Cloud SQL. Let's go. Okay, so let's go. We have it. Task 1. Create a Cloud SQL database. Click SQL. Dismiss. Create instance, choose MySQL, WordPress DB. So SQL, dismiss, create instance, choose MySQL. Instance ID will be this one. Type a password. My password will be this one. Okay, and then enterprise as cloud as SQL edition and US Central 1. But where is so enterprise zone any database version MySQL 5.7. shit, why did he put all of this in a disordered fashion? Any, okay. So literally it was any. Expand, show configuration options. Expand machine configuration. Few points to consider. Shared course machines are good for prototyping and are not covered by Cloud SLA. Each virtual CPU is subject to a 250 megabyte per second network throughput cap for peak performance. Each additional core increases the network cap up to a theoretical maximum of 2000 megabytes per second. For performance-sensitive workloads such as online transaction processing, a general guideline is to ensure that your instance has enough memory to contain the entire working set and accommodate the number of active connections. Dedicated core, and select one virtual CPU, 3.75 gigabytes. Next, expand the storage section, then choose storage type and storage capacity. Few points to consider. SSD is the best choice for most use cases. HDD offers lower performance, but storage costs are significantly reduced. So HDD may be preferable for storing data that is infrequently accessed and does not require very low latency. There is a direct relationship between the storage capacity and its throughput. Click each of the capacity options to see how it affects the throughput, or set the option to 10 gigas. So where is the throughput, network throughput, and disk throughput? Okay, so we were talking about the disk throughput. So for 10 gigas, we have a low throughput, then it grows and grows and grows. Okay, so we reached the maximum already with 500 and nearly the maximum with 250. Okay. Setting your storage capacity to low without enabling an automatic storage increase can cause your instance to lose its SLA. Okay. Expand the connections section, select private IP. In the network drop-down, select default. Click Setup Connection button that appears. Enable API, use an automatically allocated IP range. Okay. Use an automatically allocated IP range, create connection. Click Create Instance on the bottom of the page to create a database instance. It's taking some seconds to create the IP ranges, the connections. So we just set it up, this instance to have a private IP through the default network. And we allocated an automatic range of IP addresses for our instance. Now we can create it. Okay, it's being created. It will take some more seconds. You might have to wait for the private IP change to propagate before the create button becomes clickable. So yeah, now it will take a bit. Okay. Let's see if it's already, no. Then configure a proxy on a virtual machine. When your application does not reside in the same VPC connected network and region as your Cloud SQL instance, use a proxy to secure its external connection. In order to configure the proxy, you need the Cloud SQL instance connection name. Okay. The lab comes with two virtual machines pre-configured with WordPress and its dependencies. You can view the startup script and the service account access by clicking on a virtual machine name. Notice that we use the principle of least privilege on only allow SQL access for that VM. There's also a network tag and the firewall pre-configured to allow port 80 from any host. Okay, so we go to compute engine. And there's already WordPress proxy. Download the Cloud SQL proxy and make it executable. So SSH into the SQL proxy. Okay. Download the SQL proxy and make it executable. Okay. So with wget, we get this file here. And then we modify and we name it like this. And then we modify it with cmod interpret this cmod. Execute permission to a file with directory. Okay. Okay, then in order to start the proxy, you need the connection name of the Cloud SQL instance. Keep your SSH window open and return to the Cloud console. Click on the WordPress DB instance and wait for a green check mark indicates that it's operational. Not the connection name, it will be used later and referred to as connection name. Okay. WordPress. Connection name. Okay. In addition, for the application to work, you need to create a table. Click database. Databases, right? Click create database. Type WordPress, which is name of the application expects, and click create. I cannot. I need to wait it to finish creating the instance. So while this return to the SSH window and save the connection name in an environment variable. Okay. So we're doing this to save time. Verify that the minimum variable is set. Okay, the connection name should be printed out. To activate the proxy connection to your Google Cloud SQL database and send the process to the background, run the following command. So this is the executable, and we give it this parameter. The start cloud of the proxy, utility for connection is executable file. Instance connection, this is an environment variable that typically holds the connection string for OK. Specify that the connection should use the TCP protocol OK, and runs the process in background so you can continue using term for other commands. Okay. So the final end, it's the piece which will run the process. We'll send the process to the background. Okay. Now let's see if we finally have this instance active. It's taking time. It's okay. Okay, then the proxy will listen. Okay, so we need to go back until task 2, verify everything. Connect application to the cloud instance. So in this task, you will connect a sample application to the cloud instance. Configure the WordPress application to find the external IP address of your virtual machine. Query its metadata. What? So I imagine that these commands shall be executed on WordPress proxy. The command says okay, now I think it will not happen anything as I still not. Oh yeah. Specify the following, replacing with the password you configure upon machine creation. Leave the remaining setting as the defaults. So you're using localhost as database IP because the proxy you initiated listens on this address and redirects that traffic to your SQL server securely. Okay. Let's see if it's completed. Oh yeah, finally. So now we can do a lot of the remaining tasks from before. Check. Okay. Now we did all of this. We need to create the database. Create database, which will be called WordPress. Created. Database created. We did all of this. Now we need to execute this command in here. Okay. Okay. Check my progress. Okay, then we have this and we already executed it. Okay, so it's the same as here. Submit. All right, Sparky, you've made it through this part of the installation. Bad and well. Go to the WordPress proxy external IP address. Okay, let's go. Configure, click submit. When a connection has been made, click run the installation to instantiate WordPress and its database in your Cloud SQL. Once complete, populate your demo site information with random information and click install WordPress. Okay. You won't have to remember or use these details. Starting WordPress might take up to 3 minutes because it propagates a status to your SQL server. When you server, remove the text after IP address in your WordPress address and press enter. Log hello world. Welcome to the WordPress. Okay. Connect to the Cloud SQL via internal IP. If you can host your application in the same region and VPC connect to the network as your program, you can leverage a more secure and performant configuration using private IP. By using private IP, you will increase performance by reducing latency and minimize the attack surface of your Cloud SQL instance because you can communicate with it exclusively with the internal IP address. So we go to the WordPress DB, not the private IP address of the cloud server. It will be referred to as, okay. We can just go there. All instances, private IP address. On the navigation menu, click Compute Engine. Compute Engine instance. Notice that WordPress private IP is located at US Central 1, where your cloud is located, which enables you to leverage a more secure connection. Copy the external IP address of the WordPress private IP, paste in a browser window and press enter. Click let's go, continue site. Let's go. So shall follow and leave the remaining settings. Okay. So okay. WordPress root. The password is this. Database host. SQL private IP. What? Private. Wait a moment. Private IP address. Okay, have it. Oh, so it was right. It was just this one. Okay, so click submit. Notice that this time you're creating a direct connection to private IP instead of configuring a proxy. That connection is private, which means that it doesn't egress to the internet and therefore benefits from better performance and security. Run installation. An already installed window is displayed, which means that your application is connected to the cloud SQL server over private IP. In your web browser address, remove the text after the IP address. Hello world, you will present okay. So in this lab, you create a Cloud SQL database and configure it to use both an external connection over a secure proxy and a private IP address, which is more secure and performant. Remember that you can only connect via private IP if the application and the Cloud SQL server are located in the same region and are part of the same VPC network. If your application is hosted in another region, VPC or even project, use a proxy to secure its connection with the external connection. So we created, first of all, a database. So then to configure the proxy, we downloaded the proxy executable. We made it executable. We WordPress connection name, okay. Databases, create database, blah, blah, blah. Then we executed, we gave the connection string to the Cloud SQL proxy executable, and the proxy was executed and listening on this port. So now when going here, we're saying to the WordPress proxy, to the WordPress machine to communicate on this port, because there the proxy was listening and it would redirect. Traffic to our instance because it knows the SQL connection. So let's end the lab. Okay. Therefore, we completed this lab here, and now we can proceed. Let's see what's next.
In this lab, you created a Cloud SQL database.
We have this lab review, which is
You
always
compute engine.
a long video. repeating the same operations
And it
we
is
already
going
did.
to... If Cloud SQL does not fit your requirements because you need horizontal scalability, consider using Cloud Spanner. Cloud Spanner is a service built for the cloud, specifically to combine the benefits of relational database structure with non-relational horizontal scale. This service can provide petabytes of capacity and offers transactional consistency at global scale, schemas, SQL, and automatic synchronous replication for high availability. Use cases include financial applications and inventory applications traditionally served by relational database technology. Depending on whether you create a multi-regional or regional instance, you'll have different monthly uptime SLAs, as shown on this slide. However, for up-to-date numbers, you should always refer to the documentation, which you'll find in the link section of this video. Let's compare Cloud Spanner with both relational and non-relational databases. Like a relational database, Cloud Spanner has schema, SQL, and strong consistency. Also, like a non-relational database, Cloud Spanner offers high availability, horizontal scalability, and configurable replication. As mentioned, Cloud Spanner offers the best of the relational and non-relational worlds. These features allow for mission-critical use cases, such as building consistent systems for transactions and inventory management in the financial services and retail industries. To better understand how all of it works, let's look at the architecture of Cloud Spanner. A Cloud Spanner instance replicates data in n cloud zones, which can be within one region or across several regions. The database placement is configurable, meaning you can choose which region to put your database in. This architecture allows for high availability and global placement. The replication of data will be synchronized across zones using Google's global fiber network. Using atomic clocks ensures atomicity whenever you are updating your data. That's as far as we're going to go with Cloud Spanner. Because the focus of this module is to understand the circumstances when you would use Cloud Spanner, let's look at a decision tree. If you have outgrown any relational database, are sharding your databases for throughput, high performance, need transactional consistency, global data, and strong consistency, or just want to consolidate your database, consider using Cloud Spanner. If you don't need any of these, nor full relational capabilities, consider a NoSQL service such as Cloud Firestore, which we will cover next. If you're now convinced that using Cloud Spanner as a managed service is better than using or re-implementing your existing MySQL solution, see the link section for a solution on how to migrate from MySQL to Cloud Spanner.
Okay, next activity.
Let's now talk about AlloyDB. AlloyDB for PostgreSQL is a fully managed, PostgreSQL-compatible database service that's designed for demanding workloads, such as hybrid transactional and analytical processing. AlloyDB pairs a Google-built database engine with a cloud-based, multi-node architecture to deliver enterprise-grade performance, reliability, and availability. AlloyDB automates administrative tasks, such as backups, replication, patching, and capacity management. AlloyDB also uses adaptive algorithms and machine learning for PostgreSQL vacuum management, storage and memory management, data tiering, and analytics acceleration. AlloyDB provides fast transactional processing, more than 4 times faster than standard PostgreSQL for transactional workloads. It's suitable for demanding enterprise workloads, including workloads that require high transaction throughput, large data sizes, or multiple RAID replicas. AlloyDB provides high availability and a 99.99% uptime SLA, inclusive of maintenance. AlloyDB also provides real-time business insights and is up to 100 times faster than standard PostgreSQL for analytical queries. Built-in integration with Vertex AI, Google's artificial intelligence platform, lets you call machine learning models.
Okay.
If you are looking for a highly scalable NoSQL database for your applications, consider using Cloud Firestore. Cloud Firestore is a fast, fully managed, serverless, cloud-native NoSQL document database that simplifies storing, syncing, and querying data for your mobile, web, and IoT apps at global scale. Its client libraries provide live synchronization and offline support, and its security features and integrations with Firebase and GCP accelerate building truly serverless apps. Cloud Firestore also supports ACID transactions, so if any of the operations in the transaction fail and cannot be retried, the whole transaction will fail. Also, with automatic multi-region replication and strong consistency, your data is safe and available, even when disasters strike. Cloud Firestore even allows you to run sophisticated queries against your NoSQL data without any degradation in performance. This gives you more flexibility in the way you structure your data. Cloud Firestore is actually the next generation of Cloud Data Store. Cloud Firestore can operate in Data Store mode, making it backwards compatible with Cloud Data Store. By creating a Cloud Firestore database in Data Store mode, you can access Cloud Firestore's improved storage layer while keeping Cloud Data Store system behavior. This removes the following Cloud Data Store limitations. Queries are no longer eventually consistent. Instead, they are all strongly consistent. Transactions are no longer limited to 25 entity groups. Writes to an entity group are no longer limited to 1 per second. Cloud Firestore in native mode introduces... If you don't require transactional consistency, you might want to consider Cloud Bigtable. Cloud Bigtable is a fully managed NoSQL database with petabyte scale and very low latency. It seamlessly scales for throughput, and it learns to adjust to specific access patterns. Cloud Bigtable is actually the same database that powers many of Google's core services, including Search, Analytics, Maps, and Gmail. Cloud Bigtable is a great choice for both operational and analytical applications, including IoT, user analytics, and financial data analysis, because it supports...
Let's get a quick overview of memory store. Memory Store for Redis provides a fully managed, in-memory data store
Also
service
memory
built on scalable, secure, and highly available
something I
infrastructure
want to
managed by Google.
study. I want
Applications
to
running on
take
Google
the
Cloud.
whole cloud data engineer certification. I will need to deep on that. What data storage service might you select if you just need to migrate a standard relation database running on a single machine in a data center in the cloud? Which data storage service provides data warehouse services for storing data, but also offers an interactive SQL interface for querying the data? BigQuery. So which Google Cloud Data Storage Service offers AC transactions and can scale globally? Spanner. Yoo-hoo. So we've finished this section.
In this module, we covered the different storage and database services that Google Cloud offers. Specifically, you learned about Cloud Storage, a fully managed object store; File Store, a fully managed file storage service; Cloud SQL, a fully...
In this module, we will cover resource management. Resources in GCP are billable, so managing them means controlling costs.
Okay, so I will separate this topic. Therefore, I will do this module in another video. So I will just stop this video here. It will be a short one today. Maybe just later I will do the module about resource management, and who knows, I may do all together also the resource monitoring. They look like they both have just one lab, so they may be doable in like a bit more than an hour. Therefore, see you later. Thank you very much for staying with me in this video, and